Hello, my name is Dante De Niro, and this is my Lab 1 deliverable. To start off, we are going to show off just the basic topology that Container Labs can illustrate. Um, so this will just basically show which devices are active and the hardware connections that are established. So you can see the web server is over here, R5, R4, R3. Switch 3, switch 4, R1 and R2, and then switch 2 and switch 1. And then you can see the hosts are connected on this side. So feel free to pause if you want to look at the different Ethernet connections. Additionally, I'll have an IPAM here. So this will also essentially show which interfaces are where and connected to what, and which IP addresses are assigned to which interface. So we'll have all the routers, all the switches. The routers will have their actual Ethernets, and then they'll have sub interfaces as well. Sub interfaces for routers were largely used for the management network. We also have IPv6 over here, so you can also see the IPv6 addressing throughout the routing infrastructure. And then here you'll see that we'll have the different switches and then their SVIs, again, for management reasons or management purposes. This is more just like a breakdown of the subnet that we are using for our management and which VLANs they're associated with. So the R1, R2, R3, R4, switch 3, switch 4 grouping is in VLAN 200, and then the R1, R2, S1, S2 grouping are within VLAN 201. So I also did VARP in order to create redundancy in case of a singular router failure. And this is basically just the virtual IP addresses that are being advertised down to the clients and the associated VLANs. This just gives, again, a summary of the subnets that are used for the different hosts. So moving on to connectivity, I'll first just start by kind of pinging things for the management network. This is just the management network. So this is on my VM. I'll start by just pinging different addresses just to show functionality that I can reach those networks. And then I'll kind of walk through how that was configured via routing. So this 201.2 is going to router 2 on the host side of the network. So being successful. And then I can also just ping that same interface on the other side, or the other interface on the other side showing the other management is working. So I can ping both of them. And then I can ping an SVI that is in the 201 network. So this would just be switch 1, so that you can see that is also working. And then I can also just ping, so like this is router 3. I kind of made it simple. So router 3, and then router 2, router 1. And then I can also ping. So I also did I did VRRP for between R3 and R1. So I should be able to ping the default gateway, which is being advertised to me. So that's some of the management network routing. If we do a show IP route, you can see these are directly connected. So this will be directly connected. This is also directly connected on those sub interfaces. And if it goes something like S4, those routes are also being propagated. So yeah, I have full connectivity there. Just do a show run. I guess I'll do it on here. So this will fall largely in line with redistributed connected. So this will redistribute the 201 network to R3 and R4. I'm also advertising this network as well, just for, I guess, redundancy. That is probably not needed. And then, so yeah, that is basically how my network is running. I'll show you S1 and S2. I guess I'll just show you S1. Whoops. S1, I had to enable some form of routing in order to get to the network. So I just have just a static route. I could likely change this later to, I guess, put it in the OSPF neighborship so it's kind of more dynamic. But I guess just for this purposes, I just kind of need to know how to get out and where to send packets back. So again, you can see the SVI here. Yeah, so I basically just enabled routing, and then I have a singular route just so I know how to talk back to the NMAS system. SW2 is configured similarly. Same thing as R2, so I'm also redistributing connected just so there's alternating paths. So yeah, let's go to host 1. This is host 1, as you can see here. And then I'll just, again, kind of start by pinging things, and then I'll kind of walk through the different routing that was done. So yeah, let's ping. Okay, so we'll start by pinging 6.10, which is my web server. Again, I can show that as well. So ping is going to be successful here. I can also do a curl to get the web page. This is just, I just used a basic HTTPD container, and this is just whatever the basic HTML page was. So it works. I can get whatever is being shown. Additionally, I can ping between the hosts. So I could do it 120 100. So this will be host 2. So again, ping successful there. So yeah, we can kind of go through some of that routing here. Again, this is largely responsible. So I'm redistributing my connected routes, which are my host networks, into OSPF. So this will allow R3 and R4 to see those host networks. I'm also specifying this here. This was largely let me see, give me a sec. Oh yeah, yeah, right. I'm just enabling this on, right, that's how OSPF works. So I'm just enabling this on this interface so it speaks OSPF, and then I'm also enabling it on the management network as well. So that is also propagated as well. So I also did router rip. So this is basically to create a relationship. So I am neighbors with R1 and R2. Let's see, show IP rip neighbors. So this is R2. So I am neighbors. However, if you do just show IP route, these are not going to be shown in here, largely because the connected routes are always going to have a lower admin distance, so it's always going to show up in the routing table opposed to that, which hence why we do redistributed connected. We can go back on R3. So here you can see I have all the networks good to go. So I'm able to ping the hosts. I have connectivity to the host. I also have connectivity to the management network. And then all of the other interfaces as well. Do a show run. So again here, we're redistributing. This will be on the way back. So our BGP routes are going to be redistributed into OSPF. And then we're just enabling those interfaces to speak OSPF, and then some of the IPv6 routing stuff, which I'll go over in a little bit. These were largely split up into address families. Let me see, show run. Do I do address families here? Yeah, so for IPv6, it seemed like I had to do some type of address family, which I wasn't super familiar what it did. But when I was when I was troubleshooting, it pointed me to this. It says something like address family not enabled. So I just threw basically all of these network statements in an address family and activated the neighborship, which then allowed me to propagate the routes. So I am doing show IP BGP. Is there like a summary? So I'm doing eBGP between R3 and R4, which I can show again. So I'm doing eBGP between R3 and R4, just essentially because they're in the same network and they're kind of owned by the same thing. So it makes sense to do IBGP. And then I'm doing eBGP between R5 and R3 and R4 respectively. R4's configuration is going to look very similar to this. So I basically just show you one, and you kind of understand what I did on R4 as well. So yeah, basically a lot of redistributing. So again, redistributing OSPF. So I have those OSPF routes, and I can connect, and I can send those statements up towards R5. So R5 will then also be able to know about all my OSPF learned routes, which means if I know about those routes, I'll have full connectivity back down to my hosts. So I can go ahead and show you R5. So here again, we see our BGP routes. I did a multipath here again, so I have multiple paths to any one of the networks essentially. Any one of the networks that really matters, right? So I have full connectivity all the way down to my host. I also have connectivity back to my management network, which actually now looking at this, I might want to change because it doesn't really need that. So yeah, let's go ahead and show. I did the same thing, classic. So here again, I'm doing eBGP as shown. So this is going to be, I think this is router 3. No, this is router 4. So this is router 4, this is router 3. But anyway, regardless, so I'm just doing an eBGP neighborship with them, and then again for v6, which I will go over in a second. So yeah, and then I'm basically just advertising this one network back down so that my hosts know how to get to the web server because it's connected to the other end of this, and then they can also get back. So every router will have all the routes to all the networks, which again could be potentially a security risk that I might want to change in the future through ACLs or whatever, just to kind of limit where can go where can go to what network and stuff like that. Obviously, to segment the management network from the rest of the production network. So I mean, you can kind of see this. It works. Whoops, maybe not. Oh yeah, it does. Okay. So this is my web server. Wait, what? Okay, that's my web server. The other one was just the management network that Containerlabs hosts. So this is my actual IP that is assigned outside of the management network space. So it works there. I think I already did a curl. Yeah, I did a curl. So you can see I have full network connectivity all the way through the network. Now we can do a little bit of v6ing. So this is host 3. If I just go exit, yeah. So I'm on host 3. Just do an IPA. Okay, good. Disregard kind of this. I was just doing some testing. I kind of had indifferent IP address or VLAN separating for a second. But you can see that it also will take this one. This is just kind of old, so this could be deleted. I did my IPv6 addressing to the host via stateless DHCP or like DHCP v6. So I just did an IPv6 enable on these interfaces and then obviously assigned a VLAN tag via the switch. And so these are going to get propagated down. So let's see if I still have, yeah, so this, again, I'll go back on the web server in a sec just to show that this is the correct address. So I just pulled this straight. So this is the web server's IPv6 address. So you can see that I have full connectivity all the way to the web server. If I go on the web server, you can do an IPA here. Oh yeah, here. So you can see this is the same address here. Let's go ahead and paste that. Let's see, AFF, FECF 41. So I'm pinging that. This is my web server. So basically shows some type of full connectivity. So for the routing for this, again, it's very similar to what I did for v4. I just did dual stack throughout the entire environment. So if you did it here, 1, 2, 3, 4, 5 is going to be all of the router connections, including 6, as we just saw. This is where the web server is hosted. And then 10 through 40 are the host networks. Again, 40 is kind of old because I read the topology a little wrong. I thought it was 1, 2, 3, and 4, or 10, 20, 30, and 40. So I kind of added this network, but it's essentially redundant. I fixed up the VLAN, so now essentially I just have an old address on H3, but I essentially just have an extra VLAN. So this is can just be disregarded. But this will just basically show. So I did a similar thing here. Run. Let's just do a run. I don't know what the. So this again is working with redistributed connected. So again, I'm going to be. Oh, this is what this is for. Sorry. So this version, IPv6, is my IPv6 version of OSPF. So again, I'm redistributing those connected routes in order for R3 and R4, and then as well as R5 to eventually get the host networks, v6 subnets. So v6 is a little different for assigning. So you basically just do it on the port itself. Where is it? So here. So you basically just assign which interface you want to be enabled and participate in the OSPF process. Additionally, we can show, let's go back to R3. So similar thing here. I'm going to be redistributing BGP, so I'm going to get that route back. It's already being redistributed, connected, so I don't need to redistribute anything else. Show IP route. Oh, whoops. And then, so again, you can see that all of these are shown. So these are going to be all the router connections, and then these are the the hosts. So yeah, again, similar thing. You just do you configure it on the actual interface configuration itself. See if I can show that again. So again, so 3 is pointing down to, well, it's in the same subnets as 3, 4, 1, and 2 are all the same subnets. So this is the only one. Ethernet is that connection there. So you just enable it there. again, when I was referring to BGP, it seems like IPv6 needs to be in an address family. So very similar configuration, right? With it even uses the same AS like kind of process, so you don't really need to change anything there. You kind of just add the v6 routes that you want to propagate up to R5, and then you basically you'll just activate these here. So this is all working here, and then if you go to R5, so this will have every v6 network, hence the full connection. Let's see if we can do a show run. Again, see, same thing, kind of just working within the same AS, doing the same kind of EGP neighborship relationship just with v6, and then activating those neighbors, and then advertising the network down towards the different hosts. One last thing I guess I can kind of show, I can ping between. Oh, I guess I'll show you that DHCP is in fact working. Oops, exit. I'll show you on the router. I guess I can also show you my DHCP config. As mentioned, as you were mentioning, I might want to do some type of like DHCP redundancy just in case R2 happens to go down. R1 could potentially also become a DHCP server. But for now, we kind of just have this. So separated subnets, basically just kind of gave it a name. And then you're going to take that, and I took those and then just enabled DHCP on the interface itself. Oh yeah, here. So this is my VARP essentially. So like VARP will just do a similar, or you just do the same IP address. You have to do a virtual MAC as well. So you do a virtual router address, and then this is also going to be the same on R1 as well. So this command is the same on R1 as well. I also am doing virtual routing for v6. So my v6 network is also VARPed. Yeah, so I kind of did on the SVIs as well. It's also kind of another thing I could point out. I did most of my configurations on SVIs. The reason I did this largely because I was thinking my sub interfaces were not working correctly, so this was the only thing I ever got to work. But then I realized ended up fixing my sub interface configurations. It was a little bit different for my management network. So worst case, it's working now. Worst case, if this stops working, or if I have to do some different configurations, I'll go back in and change these to sub interfaces instead. But basically, this is doing the majority of my routing, and then I have them. This will kind of tunnel, I suppose, this VLAN connection into a routing interface. So a little roundabout way of doing that, but I got it to work. So again, if I get any problems, I don't really know if this is best practice, but I thought this was kind of their way of doing sub interfaces, which again I was wrong. But again, I got this to work, so it works fine. The VARP configuration works fine, so I'm just gonna leave it for now as is. Again, so showing DHCP, you just enabled that on the SVIs itself, and then this will propagate down to the hosts. So we'll do a show IP DHCP. Does that work? DHCP server. So here you can see I have some leases. This was just for testing. I really only have one. And then again, this was redundant. So yeah, I'm getting leases here. I can show that. Where am I at? I'll go here. This should be one. Let's just, no, I'll go with this. Show on host one. could do a udhcp-i. Give me a sec. Let me just confirm my Ethernet address or my Ethernet port number. Okay, so eth1. So you could do a udhcp-i. This is just a utility that does DHCP client stuff. So similar to DHCP client, I think was the other one. I think this just comes pre-built with Alpine. So yeah, I'm using Alpine Linux for my hosts, and then I'm using Arista EOS for my switches and my routers. And then my web server is also an Alpine Linux image, but again, the HTTP specific container, because that kind of already has a pre-built like server running and a web page, so it was very simple to set up. So let me just finish this. ETH1, you'll get an IP address. Lease obtain. So show that it's kind of working there. What else? I showed a curl. Let me see. Oh, I guess I can kind of go over my lab. Kind of see some of the fun stuff I was doing within. Oh my god. My Containerlabs file itself. So here is I'm basically setting up and adding the necessary packages, doing some routing here just to have it kind of preloaded, and then this is the important part. I'm basically just telling it to also listen on the IP address that I specify at port 80. This allows me to go to that website and make sure that it's actually linked to the proper interface. So yeah, again, using Alpine Linux, just kind of doing some basic, updating and adding a few packages that are used for troubleshooting. And then I'm running kind of this command that I just showed. This just does it in the background. This will obtain an IP address kind of at startup, essentially. And then I'm kind of just deleting this address because it'll give like a pre-default that will just point to the Containerlabs IP address, so I don't really want that. So I kind of just delete that, and then it will obtain a DHCP server or a default gateway from the DHCP server. So then this will also, the one that is implemented will then be replaced by that one. So this is how I do my host connection. This is basically my VM, which is what this is. My VM made up Ethernet address, and then or Ethernet, and then this is connecting to switch 3. So this will just create a basic Ethernet connection. So this is largely running my network or my management network. So that's what that's doing. And everything else is kind of basic. So yeah, that is my Lab 1 deliverable. And thank you for listening.